afternoon, ladies and gentlemen. My name is Brian, and as you heard, I'm an SRE over at Twitter. So we've heard some really excellent talks this weekend about what it means to be an SRE. There was a talk yesterday about culture of an SRE. There was a really great talk just before lunch about, how to set up a scalable service. I wanted to give you a couple of narratives wherein I dive a little bit deeper into a couple of stories. But first, let me tell you about myself. I've been an SRE at Twitter for 3 years. I've been doing something in that similar-ish space back when it was called, sysadmin or DevOps, whatever, for about 10 years. About 6-ish years ago is when I first got introduced to Python and have fallen in love with the language. And it was around that time I also started working on larger scale installations. Quick show of hands, who here works on or has worked on what you would consider a large scale? Say maybe several thousand or more nodes of compute. Just a handful of you. Okay, cool. So this may be review for you, but hopefully we all learn something, because a lot of the stuff that I talk about, I end up taking away some new bit of knowledge that I never thought I would have ever expected to learn, even after so many years. So, oh yeah, and I'm totally serious all the time. But again, this talk is going to be about narratives, where I dive a little bit deeper into a couple of issues. And I wanted to highlight these to you because whether you're on a large install, small install, you're probably going to encounter stuff like this. But hopefully I can give you a little spin about what it means to also do these things at scale. This talk is not necessarily about what I would consider the right way or a best practice talk. This is just a couple of fun stories for you. So we've heard a little bit also in other talks about what is an SRE, but what I think an SRE is a little bit of all these things. I've heard SREs considered a SWE with a different focus, more about what's going on outside of the service as opposed to just what the service itself does. Not that we don't also pay attention to that. SREs, we tend to take more preventative measures. We don't just put out the fire, we clean up all of the kindling that's around so that it doesn't catch fire. We work a lot with other SWEs, especially at other SREs, especially at larger organizations. And I know I take pride in making sure I understand what my customers, both upstream and downstream, need to understand about my own service. We focus on all of these things, making sure a service is stable, that it's efficient, that it's secure, that it can stay on its feet. But we also end up running the crash cart from time to time, because often in our history, in our industry, SREs tend to have a lot of experience with firefighting. And we often get pulled in because of our experience with firefighting, which is what helps us be uniquely qualified to help make sure those fires don't light up to begin with. So that's my little 2 bits about what an SRE is. So let's get into my first little narrative here. I got a ticket one day from our Hadoop team that said, hey, your service that runs on all of our tens of thousands of boxes, it's not running on this one host, and we wanted you to take a look at it, make sure there wasn't a deeper problem going on. So what do I do as an SRE or other? I start looking at the host, I start looking at the logs. The logs may likely lead me to the code, and I keep following it to wherever it needs to go. So this is an actual snip from our log. We have a service that fetches secrets from a remote API, drops them onto the box, and fuse mounts them so that way they're only available to a specific user on the box, which means it requires the fuse libraries. If you're not familiar with what the fuse library is, it's an in-memory file system that is user space specific. File system, user, fuse, yay. But the libraries for this system aren't there. What's going on? Why can't our service that has been running perfectly happily on everywhere else can't find this? Well, I quickly say, well, are the fuse libs there? Well, I say, oh, they are there, so there must be some disconnect. And so I reach back out to the service owner of Hadoop, and I say, it's just one host. What do you say we just wipe it clean and move on in case this thing's an edge case? This is one of the fun things you can do successfully at scale. If you have 10,000 nodes and one's broken, throw it over the fence and see if it comes back or not. Because you often have weird corner cases that never come up again. But of course, time broke in this one and it turned out not to be the only issue. So we found out that it wasn't just wasn't a problem with one host, but a small subset of hosts. So again, Hadoop cluster, it was still relatively small, about 1% of the fleet, but we weren't sure if this was a systemic issue or not. So we had to dive in a little bit deeper. One of the things to consider when issues like this come up, was it a recent deploy that maybe triggered this? Did we introduce a bug? Was there a config change? Was there a downstream dependency that decided to flip itself? We're not necessarily using a Fuse library that's from some custom build. We're not building it internally. We're just using standard Fuse as CentOS packages it up and just making sure that it's solid. And so what's going wrong? You know, initially at first blush, everything looks consistent except that this handful of hosts can't find the Fuse library. So deep breath, we're going on an adventure. So let's go back to that little log snip. Now, I'm sure, how many of you have had to go log spelunking to find out where there's a bug going on in code? Of course, all of you do. That's excellent. So this is nothing new. But I see that the log error is from a shared library. It's from the FusePy library, not something specific to our code. So after crawling through my own code just to make sure that nothing out of sorts is going on there, and of course making sure that everything's consistent, same version on the broken host as on all the other ones, I get down to looking at the actual code for the Fuse library. So that's the error that's raised. It's looking for libfuse path, and we see that it's calling this function find library on a whole bunch of different modules. And that tends to be the one that we're looking at more for a Linux operating system. So we dive deeper into the actual Python library, and we see that it's calling ctypes, which is where the find library function comes from. Ctypes calls the library of shared objects that is distributed onto a Linux system. Now, if you're familiar with Python, all of your shared libraries are made available through the environment library Python path, which has a long concatenation of directories that say where all of your shared libraries and imported libraries and third-party libraries end up living. But how does a whole Linux operating system do this with shared libraries across all environments? So we see that it's calling ldconfig, GCC, and a few other things. Now, I've never in my career, again, over 10 years, had to deal with ldconfig. This was new to me. How many of you have had to deal with ldconfig in your careers? See, that's maybe like a quarter of the crowd right there. Awesome. So the rest of you get to learn something new today. It's awesome. I love this. ldconfig creates all the necessary links and cache to bring together all the shared libraries that are in all of these different directories, userlib, lib64, et cetera, et cetera. So let's start diving through the code. Run find library on the broken host, nothing happens. Compare it to a good host, oh hey, there's a library, awesome. So where are those libraries? Well, on both hosts, our exemplar host and our broken host, they're there on disk. But ldconfig, which spits out the list of all the shared libraries, pulls it from a cache, doesn't have all of the libraries on the broken host. There's only a small fraction of them where they're actually there. So we actually get down to where we see there is a broken cache on this box. So that's our root cause. We still don't know exactly why LDSO cache is not populating and ldconfig isn't loading this stuff. But at some point, I have to cut off and say, well, other SRE who actually manages this particular fleet of hosts, this is something you might want to look into just a little bit further. And what does he do? First, he tells me, oh yeah, well, we're running the older operating system, and so we can only spend so many cycles of time trying to fix that. And ultimately, the end result, Just what we did before. We grab those small 1% of hosts, and we wipe them clean, and we throw them over the fence. So far, this seems to have been a one-off case for these small batch of hosts, and the problem hasn't come up. Now, I know what you're wondering. Brian, why aren't you taking us deeper into what LDconfig does? Well, this is one of the other issues that you end up having to do at scale, is some compartmentalization. And you have to say, okay, here's the area that me and my team have to work on, and here's the area that you and your team have to work on. And we work together to the best of our ability, but at some point we have to cut our losses and move forward because we have to keep Twitter up and running, right? So if this were to come back, then we would pick up from exactly where we left off and dive just a little bit deeper, especially if we saw this on our more current fleet of hosts. So log spelunking is always the right place to start. And we now know a little bit more about how Python loads shared libraries from the kernel. We know a little bit more about how to operate at scale, which isn't always clean and tidy. This is part of why Hadoop runs 10,000 hosts, so that they can throw a few away if they're broken. And we see that in pretty much every fleet everywhere you go. If you have 10,000 web servers, it's probably because you only need 9,000 of them. So next scenario, we were rolling out a change to how our agents that run on the box operate so that they can run in our edge pops. And when they're running from our edge pops, just for service discovery, there's a new requirement that they have to terminate TLS. We didn't worry too much about this internally because, hey, it's just service discovery, right? We're still terminating TLS for our own API calls, but we still have to do service discovery. So we didn't worry about it too much earlier, but because we're dealing with edge pops, which are a considerably less secure environment, we want to establish TLS. Great, cool, no problem, right? So we look through our code and we find out that service discovery is happening over the request library. So I pull up the docs for requests and I say, okay, cool, here's where we do this. We shove in the certificates into the instantiation of the client, and voila, we have TLS. Now I tested this out partially where I created a certificate, called up an API, and everything worked right. We also have to pass a verification cert for mutual TLS. Mind you, I'm also the first SRE at Twitter to start working directly with security, other than former SREs who have changed into security engineers. So this is all still really new to me. How many of you have actually specifically managed TLS certs in your environment? Okay, again, maybe like a quarter of you, probably a bit fewer. So I'm going to get into a bit about why this is critical. But TLS certs, as far as your code's concerned, it just needs 3 files passed in as arguments. Simple enough, right? So in my test environment, I spin up my code base, I fill in some variables, I populate the session instance for requests, just like documented. I load some loaders into my config file loader, and then I add some paths into my config file and say, okay, there's your pub key, your private key, your verification chain, fire it up, do the thing. It makes sense to do it that way, right? I mean, Patrick says it's okay to do it that way, right? So we try on a test host, and boom, it all falls apart again. So take a deep breath, stop thinking about punching the wall, and I start looking at everything again. So I start looking at all those certificates. I say, I've generated this cert. It's all generated off the same certificate authority. So our root CA that lives in a very secure location under lock and key is what we use for forking off all of our intermediates, which we use for forking out all of our additional certs that everything uses. This is how you manage certificates at scale. You have your most secret root at the most secure place of all, and then all of your certificates get generated as children off of that. Yet when we do this, when I put all that stuff in and I try to terminate against the service discovery API, everything explodes in the end. What's going on? I spent a lot of time running around talking to other engineers, the actual service owners for this API, for doing service discovery, the service owners in our edge pops who do the termination against that service discovery API. And ultimately, I got back to our own security engineers who are much more familiar with managing TLS and managing certificates, especially at scale. And I said, what's wrong? What did I do wrong here? So we continue to try other ways of building up our requests. We exploded out the request session, loaded in some certs. We even built out a raw socket call. This was something that a friend of mine put together. He said, well, why don't we just build out the raw socket calls and shove those certs in? Now, of course, what you may not notice, the cert paths that he's using are decidedly different than the cert paths that I was using, because he was using the certs that were generated for his API. But they're all off of the same intermediate, so everybody I was talking to said, well, they're off the same intermediate, this should all work just right, right? Quick word of warning here. What I've been going through is dangerous. It's important that as an organization, we understand how we manage our certs, because there are so many issues that come out from mismanaged certificates when operating at scale. Lisa Roach earlier talked about how important it was for her to make sure her PKI infrastructure stayed up because she wanted Facebook to stay up. We have a similar framework at Twitter, but this is all for internal service-to-service discovery and service-to-service authentication within Twitter. So just a quick snip from that most businesses do not have the visibility or the tools necessary to manage this fundamental element of cybersecurity, which when you really stop and think about it, the tools are there. We have the OpenSSL CLI. And at the end of the day, this is really just managing putting files on servers, which any good DevOps is going to know how to do. This is what we have Puppet. This is why we have all these other config management systems out there in order to be able to thoroughly distribute files onto servers under the same ownership, appropriate ownership, and so on. Anyway, back to our story. So TLS says that the client verification chain needs to agree with the server-side verification chain. And one thing I also learned from talking to the API owners is that there's a whitelist that they use for making sure that you can only do service discovery on certain endpoints. But of course, I'm an SRE and I just want to solve the damn problem and move on. So from an SRE perspective, I just want to put the right files in the right place on the right box and make sure they work and hope and pray that the downstream API that I need to talk to is going to do the right thing when I talk to them. Now, remember how I said that they were using different client certs? So after working, I'm jumping ahead of myself. I worked with the API owner, again, to get the requirements down, worked with InfoSec to ultimately find out, oh yeah, this is really where our certs are probably wrong, and I started doing some verification using the OpenSSL tool. Another quick show of hands. Who has used the OpenSSL CLI tool in your day-to-day basis? All right, and again, about a quarter of hands. So the other 3/4 of you, hopefully you get to learn something, because this was brand spanking new to me up until several months ago. When you use the X509 format against a public key, you can see dates for validity for a certificate, and then you can see the authority under which the certificate was produced. So we see this certificate was produced by Twitter, it was produced on those dates, and it was using a specific public key algorithm. That line right there is the important one to notice, this is the certificate. This is the, oh gosh, and now I'm forgetting what the CN stands for, but it's important to know. All right, what does CN stand for in X509 formatting? Does anybody know? Company name, thank you. I love this community. You folks are awesome. So we see that it's this string which is specific to our service name. Yet when we dump out the certificates from the server side, we see that the certificate name doesn't necessarily match us, and the acceptable client certificate names, I've truncated this list because it's a mile long, also doesn't match us. So I eventually found we had the wrong verification chain, which is why we're getting rejected. And so our solution was either to update the certificate chains on that API side, or I could just cheat and then temporarily, until I get that fixed, use a cert that actually works, which I did. So we changed what was being populated into the verify path, and voila, our service stood up just fine. And now we're serving certificates for secret distribution out in our edge pops, which is kind of awesome. So we had success from our test host. We know what our root cause was, where we have whitelisting. We were using the wrong verification chains. So if I jumped earlier to having a security review, I might have discovered this issue a lot sooner. And what was initially presenting itself as a code bug turned out to be a config bug. So sometimes issues reveal themselves differently like that. Yet again, though, after getting out of our test environment, we start putting that code out on our edge pops, and it starts blowing up again. What's wrong? Everything worked just fine in tests. I start looking at the logs. They weren't really showing me anything useful. They were just saying, failing to terminate, failing to terminate. So what's going wrong? The code was identical. We know the configs are identical. I hand curated them myself. What's going on? What's going on? So I go back and I start looking, and I see where I'm loading my configs. Now, without getting into too much context, this config module uses a get function which operates just like a dictionary. I think we're actually subclassing dictionary in that library. So when you get something and it's not there, you just get back none. And you'll see that we have a descendant structure, what we call TLS cert path. But the YAML begins with resolver. I typoed, which was hilarious because this was actually why my service discovery client worked in test, because it wasn't even loading certs to begin with. Yeah, I got this far before I figured that out. Isn't that awesome? So hopefully this is a lesson to you. Double check all of your code. So there were other typos that I'm too embarrassed to put on a slide, which is why we're stopping there. That, and also I'm running out of time. But it did also reveal exactly how different things were in production. So we took all this care and everything, and all my code went through multiple review process, and everybody said, hey, it looks great. And I hit that ship it button and merged code, put it out on a test host. And this is also, again, why you canary before you roll out to full production. Because if I rolled this out to all of our edge pops, that would be disastrous. So we fixed all those code paths. We fixed all those load paths from our config library, ran it on the test host, and then ran it on the canary host in our edge pop, and everything worked beautifully. So when things look perfectly fine inside the app, that doesn't necessarily mean things are working perfectly fine outside. And sometimes you need that outside perspective in order to be able to look inside and see how your service is working properly. You know, reflection, just as good a life advice as it is for SRE advice, right? So as an SRE, I pay more attention to what's going on around and outside an app as I do inside. That's kind of how we like to structure SREs, in particular at Twitter, but at other organizations, I see that as well. I still contribute to our code reviews. We still talk about overall projects all together as a team. I just pay attention to slightly different things than the rest of my team. So I also got a chance to shove in more log entries to give us more context when we started having further issues. So when you're getting ready to deploy, try and make sure your test environments closely match your production environments. And if they're different, make it clear how they're different. And when you're working with other teams, try your best to write everything down or encourage them to write everything down. There was a lot of just bumbling around over these last two issues that would have been solved with some much clearer documentation. So I've been working a lot with those other teams to try and help expand documentation to make things better. And just as in the other issue, we had what we thought was a bug turned out to be a config issue. When we actually went to production, the config issue that we thought was there turned out to be a bug in the end. Fun times. So what was the point of this whole talk? Just a reminder that not everyone knows everything. I work with some really brilliant people at Twitter, and we all talk to each other all the time, especially those of us in the SRE group, and I learn a ton from everybody that I work with. We all share information, we ask each other questions. So just like we encourage people to enjoy the hallway track here at this conference, when you're at your place of business, enjoy your hallway track there. Talk about what you're working on, ask people what they're working on. You might learn something new. And encourage people to write down documentation. Not everything is all what it seems. Dive a little bit deeper into every issue, at least until you hit a point of diminishing returns and decide to throw the servers over the fence. But taking that extra couple minutes may help you find a bug that your reviewer missed. Environments are different. We had to deal with special cases because of how things operate in our edge pops as opposed to how they do in our standard data centers. And code can express itself differently in each of those environments, which is why I was able to discover a gross bug once it actually went to a different environment. And just keep digging and trying to keep things going. We're all here for the same purpose. We're all here to try and keep our production environments moving forward. That's about all I have to say on that. If you have any questions, I'm here for a couple more minutes. You can find me outside. Oh, we done? Oh.
Yeah, we have like 5 minutes for questions if anybody has a question.
No?
I think, was it Carol that was talking about monitoring? What do you guys use? Like she was talking about Prometheus as a tool.
That
like,
was Lisa who was talking about
Lisa.
monitoring.
Yeah.
And
do you have any,
not unlike Facebook, we also have an internally built monitoring tool. Outside of Twitter, though, I have played with Prometheus, I've played with TSDB, and I've played with Grafana. I really like Grafana. I think it's really cool from a visual perspective. So, and TSDB also scales a little bit bigger. So to each their own.
does TSB use HBase or? Okay.
I'm 90% sure TSDB uses HBase, but I don't exactly recall. I think this gentleman had a question too.
Hi, I enjoyed your talk. Thanks.
Thank you.
I'm curious about the team size at Twitter. Are SRE groups, how large is an SRE group per project?
That depends on the size. So I'm embedded on 2 different teams. So each team has me only half time. But there are other teams, like the revenue team, that have like, 5 or 6 SREs because they're a much bigger product. 9 now? Oh, wow, okay. So Twitter will spread their SREs to where they're needed the most. So.
Thank you.
Sure.
Anybody else? Okay, great.
Right.
Thanks, Brad.
Thank you.